Alright, we are starting a new unit. You should have your binders completely and totally empty, so you don't need anything else except for this brand new big packet you got in class today. So, you have your data gathered from today in class. I'm going to write down what my data is and analyze my data as you analyze your data. So hopefully you graphed, and in a graph you want to make sure you always have titles and labels. So this is your x-axis and this is your y-axis. The bridge layers is the x-axis, and the breaking weight, which is the number of pennies, is the y-axis. So over 1 up 9, over 2 up 16, over 3 up 24, over 4 up 34, and over 5 up 42. Now, we're not going to connect the dots. What you can do is you can draw a best fit line. But first, let's sort of analyze how the difference between each of them. So if you do 42 minus 34, you get 8. 34 minus 24 is 10. 24 minus 16 is 8. And 16 minus 9 is 7. So this is approximately your slope. And a good title for this might be Bridge Breaking. With different lengths. So, if you look at your dots, a best fit line must go through at least 2 points. You want the points as close to the line as possible. You want about the same number above and below. And it has to follow the trend of your data, like the pattern. So it might not be linear. This one definitely looks linear, but it might be a best fit curve, so you need to follow the trend of your data. So in order to draw a best fit line, this is pretty linear, but you want to pick 2 points, and it doesn't matter what 2, as long as about the same number of points are above and below. It hits 2 points, and the dots are as close to the line as possible. So what I mean by that is this difference, the dot away from the line, is not very different. So the next question asks, does the relationship seem to be linear? And you're going to hopefully yours seems to be linear too. And if you look at the differences, if you kind of like average these, you're probably going to get something pretty close to 8, like a difference of 8. So think about what your common difference is. I'm going to put my common difference is close to 8. And that's in the table. And in the graph, it looks like a line. And you can draw a best fit line. And letter D says, suppose that you could predict a weight for 2.5. So let's go back to the table. And a best fit line is showing that you can for 2.5. 2.5 is right here. And if you trace that up, it hits right here. And that's around about right there. So it looks like 2.5 is pretty close to 20. You can also predict that by looking what's in between 16 and 24, and also that is 20. So that's how you're going to predict. You can predict from the table or from the graph. So 20 pennies. And then you're going to be asked to predict for a thickness of 6. We are going to predict the breaking weight for 6 layers, going back to the table, and this is layer 6. So again, my average slope is 8, so if you add 8 to this, you would get 50. That's one way to predict it. Another way is to 6, trace it up, and trace it over. And that also looks pretty like 50 right on. So for my data, you're going to do this for your data, I'm going to put 50 pennies. And for the table, I added 8. And on the graph, I traced up and it hit 8. And then it says to actually test your predictions, and I'm not so sure that you're going to be able to do that since you don't have paper and pennies at your house probably. So they're probably not going to be exact, but it'll probably be close. And there is error in our data gathering. And that might be, you might have a Canadian penny, you might have a different dropping method, you might not drop the exact same. The piece of paper might have shifted. So there's many different reasons that that might not be exactly right. Okay, I'm going to actually give you some data, and we're going to do a small little thing with all of us having the exact same data. So you're just going to write this at the bottom of your page. It's just going to be added on. Okay, so we're going to make a table, and it's going to say thickness. That's the thickness of the paper, and then breaking weight. So 1 layer was 12 pennies, 2 layers is 20 pennies, 3 layers is 29 pennies, 4 layers is 42 pennies, 5 layers is 52 pennies, and 6 layers is 61 pennies. Okay, so the first thing you want to do when you're analyzing data is to say, is this linear or is it something else? So you're going to find the first difference. That's one thing you're going to do. So 61 minus 52 is 9. 52 minus 42 is 10. 42 minus 29 is 13. 29 minus 20 is 9. And 20 minus 12 is 8. So it looks pretty close. The second thing you want to do is sketch a graph. So you're going to want to do this by hand as close as you can. So 1, 2, 3, 4, 5, 6. And you want to put the label. And we're going up to 61, so maybe count by 5s. And we'll just call this bridge break. So over 1, up 12, over 2, up 20, over 3, up 29, over 4, up 42, over 5, up 52, over 6, up 61. Now, you might think that this is a curve, and that's okay. You might see that this curves up. It does kind of go back down, so I don't know. And you might think that it's linear, and that's okay too. So whatever pattern you are seeing, you're going to draw the best fit line or the best fit curve. So if you're drawing a best fit line, I'd probably use a ruler. And I think I'm personally going to go through these 2 points. And there is definitely more than one right best fit line, but as you can see, this is really close, and I've got this one above and the one below. And then you could make your predictions from here and the table. So let's predict for 3.5 and for 8. So go ahead and pause and see if you can get your predictions, and then hit play and we'll see if we're close. And if you're close, that's all you need to be. Okay, so in the middle of 29 and 42 is like 35 or 36. And if you go to 3.5 and you trace it up and then you trace it over, it's about 35, 34. So that would be a great prediction. And I might predict 7 before 8. So looking at this, I'm saying, all right, I've got a couple 9s, an 8 and a 13. Probably it's pretty close to 9 or 10 that we're adding. So if you add 9 or 10, it doesn't matter, you would get 70. And if you add 9 again, you would get 79. So that'd be one way to predict. The other way would be to go out 8, 2 more over, trace up, trace over. We're going to actually have to extend this too. So 60, 65, 70, 75. So this one looks more like 73-ish. So you could have 79, 73, whatever. And that would be a great prediction. So you should be able to know if something is linear or not. You should be able to draw a best fit line, make predictions, and we tomorrow, the next day of school, we're going to do thickness, and we're actually going to see if it typically does give us linear. In fact, I'd almost kind of rather scratch that out and put length, because length we know for sure is linear, and we're actually going to test this tomorrow and come up with some more data to compare with. Alright, so you have a sheet to work on 7 through 17, skip 11 and 10D. Alright, good luck.